Long before Neanderthals became a recognizable human form, their story was already unfolding in a world defined by constant change. Eurasia, hundreds of thousands of years ago, was anything but stable. Massive ice sheets advanced and retreated, climate shifted abruptly, and entire ecosystems transformed within relatively short geological periods. To understand who the Neanderthals were, it's essential to picture this environment clearly: a vast, fractured continent where frozen valleys coexisted with dense forests and open steppes replaced woodlands as temperatures rose and fell. Survival here demanded more than strength, it required adaptability at every level. Neanderthal ancestry traces back roughly 600,000 years, emerging from populations related to Homo heidelbergensis that spread across Europe and parts of Western Asia. This early phase marked a major evolutionary test. Temperatures could plunge dramatically over a few centuries, reshaping food availability and forcing human groups to either adapt or disappear. Natural selection favored bodies built for cold efficiency: shorter limbs, wider chests, dense bones, and a metabolism optimized to conserve heat. Fossils from sites like Cima de los Huesos in Spain already show facial and cranial traits that point directly toward the classic Neanderthal form. Long before modern humans entered Europe, this lineage was already taking a very different evolutionary path. Before we dive in, drop your location in the comments and subscribe to Primal Roots if you're enjoying the journey. As glaciers expanded, northern regions became uninhabitable, pushing animals and human groups southward. When warmer interglacial periods arrived, temporary ecological corridors opened, allowing movement, interaction, and genetic exchange. Neanderthals evolved within this constant cycle of contraction and expansion. Over time, they refined behaviors that would define them: reliable fire use in damp, cold conditions, coordinated hunting of large animals, and social systems capable of maintaining cohesion in small, isolated groups. These pressures didn't just shape their bodies, they shaped their minds. One of the most striking features of Neanderthals is their large brain, often slightly bigger than that of modern humans. This was not a random outcome. Life in glacial environments demanded intense spatial awareness, precise motor control, and rapid decision-making. Tracking animals across snow-covered terrain, predicting weather shifts, and navigating dangerous landscapes required heavy cognitive processing. The elongated shape of the Neanderthal skull reflects these demands. While brain size alone does not equal intelligence, it does point to specialization. Neanderthal brains devoted more resources to sensory input and body control, a direct response to life in extreme conditions. Genetic research reveals that Neanderthals were never isolated from the broader human story. Eurasia at the time was home to multiple human lineages, including Denisovans in Central Asia and lingering populations of Homo erectus farther south. These groups occasionally crossed paths. Neanderthal DNA shows evidence of interbreeding events long before modern humans arrived on the scene. Some of these genetic exchanges affected immune responses and fat metabolism, key traits for surviving cold, unstable climates. Neanderthal biology was shaped not only by environment, but by interaction. At the same time, their cultural world was steadily evolving. The rise of the Mousterian tool tradition reflects deep technical knowledge. Neanderthals understood stone properties at an expert level, shaping flint and other materials with remarkable precision. Creating symmetrical blades and specialized scrapers required planning several steps ahead, fine motor control, and learned techniques passed down through generations. These were not improvised tools. They were the product of tradition, teaching, and accumulated knowledge. From an ecological perspective, Neanderthals occupied the top of the food chain. Isotopic analysis of their bones shows diets rich in meat from large animals such as bison, reindeer, wild horses, and even woolly rhinoceroses. Hunting prey of that size was dangerous and required teamwork, communication, and an intimate understanding of animal behavior. Their repeated success across thousands of years shows a level of mastery over their environment that contradicts outdated views of Neanderthals as crude or inefficient. Some of the most transformative discoveries, however, come from areas once thought exclusive to modern humans. For decades, symbolic behavior, art, ornamentation, abstract thought was considered unique to Homo sapiens. That assumption collapsed when cave paintings in Spain were dated to over 64,000 years ago, a time when modern humans had not yet arrived in Europe. The only possible artists were Neanderthals. Perforated shells, mineral pigments, and carefully modified eagle talons further support the idea that symbolism was part of their world. These findings forced scientists to rethink long-standing assumptions about cognitive limits. Their social lives were equally complex. Fossil evidence reveals individuals who survived severe injuries and lived for years afterward, something impossible without consistent care from others. Elderly individuals missing most of their teeth still managed to survive, implying food preparation and group support. These patterns point to empathy, cooperation, and long-term social bonds. In a harsh Ice Age landscape, caring for vulnerable members wasn't just compassion, it was an adaptive strategy that strengthened group resilience. When all these elements are combined, robust bodies, specialized brains, advanced tools, cooperative societies, and symbolic expression, a very different picture emerges. Neanderthals were not evolutionary dead ends or primitive failures. They were a successful human form, finely tuned to environments that modern humans of the time could not yet survive in. This first chapter lays the groundwork for understanding why Neanderthals continue to challenge our assumptions. Each discovery reshapes how we define intelligence, culture, and what it truly means to be human. As archaeological evidence expanded over the last few decades, the daily life of Neanderthals began to emerge with increasing clarity. What once appeared as a simple, survival-driven existence now reveals itself as a finely tuned behavioral system, shaped by experience, tradition, and deep environmental knowledge. Rather than reacting blindly to harsh conditions, Neanderthals organized their lives around predictable patterns, technological mastery, and social cooperation that allowed them to thrive for hundreds of thousands of years. One of the clearest windows into this complexity comes from their stone technology. Neanderthals were not casual toolmakers. The widespread use of the levallois technique demonstrates advanced planning abilities that rival those of later human populations. This method required shaping a stone core in a precise way so that the final strike would release a flake with a predetermined size and shape. The outcome was envisioned before the first blow was ever delivered. Such foresight reflects abstract thinking, learned expertise, and a cultural system where knowledge was transmitted across generations. What makes this even more compelling is the regional variation in Neanderthal tools. Different groups developed distinct styles based on local materials and environmental needs. These were not random differences but consistent patterns that archaeologists can trace across landscapes. In effect, Neanderthal communities possessed regional technological identities. This suggests cultural continuity, group traditions, and a sense of shared practice within each population. Fire played a central role in shaping Neanderthal domestic life. Far from being accidental or sporadic, its use was deliberate and controlled. Excavation sites reveal hearths placed repeatedly in the same locations, indicating structured living spaces. Certain areas were used for cooking, others for tool production, and some for rest. Analysis of charcoal remains shows selective use of wood types, including resin-rich plants that burn longer and hotter. In cold, damp environments where starting a fire is difficult even with modern tools, this level of control speaks to deep technical knowledge and routine mastery. Fire also transformed diet and health. Cooking made food easier to digest, reduced pathogens, and allowed Neanderthals to extract more energy from both animal and plant sources. While long viewed primarily as meat specialists, new evidence paints a broader picture. Dental calculus analysis reveals traces of cooked plants, seeds, nuts, and underground tubers. In some regions, residues of medicinal plants appear as well, including compounds related to pain relief and anti-inflammatory effects. This indicates experiential knowledge of local ecosystems and an ability to recognize the functional properties of natural resources. Clothing and shelter further illustrate this adaptability. Microscopic wear patterns on stone tools show repeated hide scraping, consistent with the production of fitted garments. Such clothing would have been essential for surviving Ice Age winters. This implies more than technical skill. It suggests planning ahead for seasonal change, storage of materials, and possibly division of labor within groups. While organic materials rarely survive in the archaeological record, their absence should not be mistaken for simplicity. Communication remains one of the most debated aspects of Neanderthal life, yet the evidence increasingly points towards sophisticated vocal abilities. The hyoid bone discovered at sites like Kibara Cave closely matches that of modern humans, supporting the physical capacity for speech. Genetic analysis adds weight to this conclusion, revealing that Neanderthals carried the FOXP2 gene variant associated with language. While the structure of their language cannot be reconstructed, the biological foundations for complex communication were clearly present. Coordinated hunting, social learning, and cultural transmission would have been nearly impossible without a rich system of communication. Social organization among Neanderthals was far more intricate than once assumed. Genetic studies from sites such as El Sidron show extended family groups living together with clear kinship ties across generations. These were not temporary gatherings but stable social units. Skeletal remains provide further insight. Individuals with severe injuries, healed fractures, and chronic conditions lived for years beyond trauma. Survival under such circumstances would have required sustained care, food sharing, and group support. These behaviors reflect empathy, cooperation, and long-term social bonds rather than short-term utility. Mobility patterns also reveal a strategic understanding of landscape and resources. Neanderthals did not wander aimlessly. Chemical signatures in teeth and bones indicate seasonal movement across territories, often following migrating herds. This required detailed knowledge of geography, climate cycles, and animal behavior. Some groups returned to the same locations year after year, demonstrating long-term planning and environment memory. In certain coastal regions, evidence shows exploitation of marine resources, including shellfish and seabirds, further expanding the range of their subsistence strategies. Perhaps the most surprising discoveries concern symbolic behavior. Objects with no clear practical function pigments, decorated shells, and modified bird talons have been found in Neanderthal contexts across Europe. These items suggest forms of visual expression, identity signaling, or social distinction. The use of red and yellow pigments, sometimes transported over long distances, implies intentional selection and cultural value. Cave markings dated to periods before the arrival of modern humans reinforce the idea that abstract expression was not exclusive to our species. Burial practices add another layer of complexity. Several Neanderthal sites show bodies placed deliberately in pits, sometimes accompanied by stone tools or other objects. The famous case from Shanidar Cave, where pollen traces surround a skeleton, has sparked ongoing debate. While interpretations vary, the possibility of intentional burial rituals cannot be dismissed. Even cautious readings suggest awareness of death and some form of structured response to it, whether symbolic, emotional, or social. Neanderthals were also highly adaptable across regions. Populations living in colder northern zones exhibited more robust physics, while those in milder southern areas showed subtle anatomical and behavioral differences. Toolkits, hunting strategies, and settlement patterns shifted in response to local conditions. This regional flexibility undermines the notion of Neanderthals as rigid or behaviorally static. Instead, they appear as a network of populations adjusting to diverse environments while maintaining shared cultural foundations. Interactions with other human groups further shaped their lives. Long before encounters with modern humans, Neanderthals experienced genetic exchange with other archaic populations. These interactions contributed to their biological diversity and adaptive traits. Later, when Homo sapiens entered Eurasia, Neanderthals were already experienced survivors of fluctuating climates and challenging ecosystems. Their long-term success suggests resilience rather than fragility. By assembling these lines of evidence, technology, diet, communication, social care, mobility, symbolism, and regional adaptation, a coherent picture emerges. Neanderthals were not defined by limitation, but by specialization. Their lives were shaped by deep knowledge of their world and by cultural systems refined over immense spans of time. This chapter reveals a species that lived with intention, foresight, and complexity, challenging outdated narratives and forcing a broader definition of what it means to be human. As research continues to uncover new details, the Neanderthal story grows richer and more nuanced. What once seemed familiar now appears unexpectedly sophisticated, setting the stage for the final chapter, where disappearance, survival, and legacy converge into one of the most compelling questions in human evolutionary history. Toward the end of the Middle Paleolithic, the world that Neanderthals had mastered for hundreds of thousands of years began to change in ways that tested the limits of even their remarkable adaptability. By around 45,000 to 40,000 years ago, their populations were no longer spread widely across Europe and Western Asia. Instead, they had become fragmented, isolated into smaller groups occupying ecological refuges where survival was still possible. This phase marks the final chapter of a human lineage that endured far longer than most human species, yet ultimately faced a convergence of pressures that reshaped its fate. Genetic evidence provides one of the clearest signals of decline. Analyses of Neanderthal genomes reveal a steady reduction in genetic diversity during the last tens of thousands of years of their existence. Small, isolated populations are inherently vulnerable. Any sudden environmental shift, epidemic, or drop in food availability can have outsized effects when group size is limited. In such conditions, recovery becomes increasingly difficult. The genetic record suggests that Neanderthals were already under demographic stress long before they vanished from the archaeological record. Climate instability played a central role in this process. The late Pleistocene was characterized by rapid and extreme fluctuations in temperature, documented in ice cores from Greenland and sediment records across Eurasia. Warm intervals were often brief, followed by abrupt returns to cold, dry conditions. These oscillations transformed landscapes repeatedly, altering vegetation patterns and disrupting the migratory routes of large herbivores that form the backbone of Neanderthal subsistence. For a species so closely tied to predictable hunting cycles, such unpredictability posed a serious challenge. At the same time, ecosystems were becoming increasingly patchy. Forests fragmented, Open steppe expanded and contracted, and coastlines shifted as sea levels rose and fell. Neanderthal groups responded by retreating into regions that offered more stable resources, such as southern Europe and coastal zones. Archaeological sites in places like Gibraltar suggest that some of the last Neanderthal populations exploited marine resources, including shellfish and fish, reducing their dependence on large terrestrial prey. This shift reflects behavioral flexibility rather than stagnation, yet it may not have been enough to counter broader demographic pressures. The arrival of Homo sapiens in Eurasia added a new dimension to an already complex situation. Modern humans began entering Europe roughly 45,000 years ago, bringing with them social and technological systems that differed in key ways. These populations operated within expansive social networks that connected distant groups, enabling the exchange of information, tools, and mates across large territories. Such connectivity enhanced resilience during periods of environmental stress, allowing resources and knowledge to circulate more freely than in small, isolated groups. Evidence from archaeological sites indicates that Neanderthals and Homo sapiens coexisted in certain regions for several thousand years. This overlap suggests that their interactions were not immediately violent or competitive in a simplistic sense. Instead, both species occupied overlapping landscapes, sometimes exploiting similar resources, sometimes adopting different strategies. Cultural differences rather than direct conflict may have played a greater role in shaping outcomes. While Neanderthal technology remained relatively stable and highly efficient, sapiens populations showed a tendency toward rapid innovation, producing diverse tools, symbolic objects, and new subsistence strategies in a relatively short span of time. Genetic data confirms that contact between the two groups included interbreeding. Today, all non-African human populations carry between 1 and 2% Neanderthal DNA. This alone demonstrates that encounters were frequent enough to leave a lasting biological imprint. Moreover, different modern populations retain different fragments of Neanderthal genes, indicating multiple episodes of admixture across Eurasia. These genetic contributions are not trivial. They influence immune responses, skin physiology, lipid metabolism, and even susceptibility to certain environmental stresses. This genetic legacy also offers insight into how Neanderthals may have disappeared. Rather than a sudden extinction, some populations may have been gradually absorbed into expanding sapiens groups. In regions where Neanderthals were already few in number, repeated interbreeding could have diluted distinct Neanderthal genetic identity over generations. In this scenario, disappearance does not mean annihilation, but integration. The biological line blurred, and what remained was carried forward within a different population framework. Technological and cultural dynamics further shaped this transition. Neanderthals relied on well-established tool traditions that had proven effective for millennia. Their strategies emphasized reliability and efficiency within familiar environments. Homo sapiens, by contrast, displayed cumulative cultural evolution where innovations built rapidly upon previous ones. This pattern allowed for faster adaptation when environments shifted. Over time, this difference may have given sapiens an advantage in unstable conditions, not through superior intelligence, but through greater cultural flexibility. Archaeological evidence from the last Neanderthal sites reveals no sign of cognitive decline or cultural collapse. Engravings found at Gorham's Cave and other locations suggest continued symbolic behavior until the very end. These markings indicate intentional abstraction and planning, challenging any notion that Neanderthals were culturally stagnant during their final millennia. Their disappearance was not the result of sudden incompetence, but of cumulative pressures that slowly reduced their ability to maintain viable populations. Disease has also been proposed as a contributing factor. Increased contact between previously isolated populations can introduce novel pathogens to which small groups have limited resistance. While direct evidence is difficult to obtain, this mechanism is well documented in later human history and cannot be ruled out. Combined with reduced genetic diversity, even mild epidemics could have had severe demographic consequences. The disappearance of Neanderthals follows a pattern seen in many large mammals facing rapid environmental change, fragmentation, decline, and eventual replacement or absorption. What sets them apart is the closeness of their relationship to modern humans. They were not an evolutionary dead end, but a parallel form of humanity shaped by different constraints and solutions. Their long survival through repeated ice ages testifies to their effectiveness as a species. Today, Neanderthals continue to influence the human story in tangible ways. Genetic studies reveal that certain immune system traits inherited from Neanderthals help modern humans respond to pathogens, while others may increase susceptibility to inflammatory conditions. This complex legacy reflects trade-offs that were once advantageous in Ice Age environments and remain biologically active today. In this sense, Neanderthals are not only part of the past, but part of the present. Beyond genetics, their story reshapes how human evolution is understood. The Neanderthal record challenges linear narratives of progress and superiority. It reveals a branching evolutionary history filled with multiple human forms, each adapted to specific ecological and social contexts. Intelligence, culture, and innovation did not follow a single path. They emerged in different configurations, shaped by environment rather than hierarchy. The growing body of evidence forces a reconsideration of what defines humanity. Care for the injured, symbolic expression, complex technology, and social cooperation were not unique to Homo sapiens. Neanderthals shared many of these traits, expressing them in ways suited to their world. Their extinction does not diminish their achievements. Instead, it highlights the fragility of even highly adapted species when confronted with rapid change. As scientific methods continue to advance, new discoveries will further refine this picture. Each fossil, each genome, and each archaeological layer adds depth through a story that is still unfolding. The Neanderthals remain one of the clearest reminders that human evolution was not a straight line, but a rich tapestry of experiments and survival. In the end, Neanderthals did not simply vanish. They contributed to the biological and cultural foundation from which modern humanity emerged. Their legacy lives on in our genes, in our understanding of resilience, and in the recognition that the human story is broader and more complex than once believed. Discoveries like these are still reshaping what we know about human origins. If you want to explore more stories about extinct human species, ancient worlds, and the science behind our past, subscribe to the channel and stay connected to the next chapter of human evolution.